Today we are going to learn how to calculate molar mass and do some conversions from moles to different unit like grams, volume, and particles. So the first step is to calculate molar mass. So you list all the elements in the compound, see how many atoms are there for each element, multiply by the atomic mass from the periodic table given to you, then add the products for each element. The unit for molar mass is grams per mole. Here is an example. So if you have Cr2, SO4, 3. So the 3 outside the parenthesis means there are 3 SO4s. So when you list out each element, you have 2 chromiums, you have 3 sulfurs, and you have 4 times 3 oxygen. You find the atomic mass of each element from the periodic table, multiply these numbers, and then add them up. So this would be the molar mass for chromium 3 sulfate. Here are some practice problems you can practice and see. This is a mole conversion map. Pause the video and copy the conversion map so that you can use this for conversion. So I'm going to do a couple of problems and then we'll practice more. So here is, and this setup is called as dimensional analysis. Here is a problem. How many moles are in 297 grams of ammonia, that is NH3? So the first thing is for you to find what's given. So the given is here, given is 297 grams of ammonia. And what you have to find is moles of ammonia. So you always start with what is given, 297 grams of ammonia. Always given over 1 times. Because we have grams here, I need grams of ammonia. And I'm trying to find moles. So I need to know in 1 mole of ammonia, how many grams are there. And here is where your molar mass goes. So the molar mass means how many grams are in 1 mole. So 1 mole of NH3, you find the molar mass for ammonia. So nitrogen is 14, hydrogen is 1.008. So it is 17.031 grams. So in 1 mole of ammonia, there are 17.031 grams. So I would put that here. So if you divide these numbers, you'll get how many moles of ammonia there are in 297 grams, which is 17.438. So if I want to round this off to right amount of sig fig, so I'm looking at my given, I have 3 significant figures. So my answer is going to be just 3 significant figures, which is 17.4 moles of ammonia. So let's do one more. So we are going to do a second problem, which is what is the mass of 1.9 times 10 to the 26 formula units of K2CO3. Formula units means the smallest part of K2CO3, like 1 K2CO3 in there. So when we have an element, If there is an element, the smallest part is atom. If it is ionic compound, the smallest part is formula unit. If it is a molecular compound or a covalent compound, the smallest part is molecules. So this is what is given. So you write down this is your given, and you have to find the mass, the grams of K2CO3. So you start with what is given. So 1.9 times 10 to the power of 26 formula units of K2CO3 over 1 times. Now I need to have formula units of K2CO3 on the bottom. And always formula units, if you look at the mole map, it has to be converted to moles. So 1 mole of K2CO3 has 6.02 times 10 to the power of 23, which is the Avogadro's number, formula units of K2CO3. So if I stop here, my formula units cross out. So the only unit left is moles. That means I'll get moles if I stop here and do my calculation. But I need grams. So I need to do one more step, which is times, because I have moles here on the top, I'm doing 1 mole of K2CO3 on the bottom, and I need grams of K2CO3. So in 1 mole of K2CO3, I have 138.204 grams of K2CO3, which is the molar mass. This is the molar mass of K2CO3. So now, if I cross out the units, the moles in moles, what unit is left is grams of K2CO3, which is what I'm asked to find. Now I have to do the calculations. So I start with my given, whatever is on the bottom you divide, and whatever is on the top you multiply. So 1.9 times 10 to 26 times 1 divided by Avogadro's number. Now when you're putting this in your calculator, make sure you have a parenthesis around this number. And when you get the answer, times it by the molar mass of K2CO3. So what I'm getting is 4.3 times 10 to the power of 4 grams. Now to 3, and it is actually 3.6. So I started with only 2 significant figures here. So my answer needs only 2 significant figures. So I would round it off to 4.4 times 10 to the power of 4 grams of K2CO3. Okay, that is it for today's lesson.